Hi there. Let's get to our example for today. If f dx equals to 4x cubed plus 3x squared multiplied by z plus 5xz squared plus 6z cubed plus 20, then second derivative of f dx equals 2. So this might seem as a little bit complicated when you see the z over there, but the only thing what we're going to do actually is we're going to consider z as a constant. So we're going to say z equals to a constant, a number. We are going to go to the FE handbook and we're going to find a few formulas that we're going to use in order to solve this. And we're going to use derivative of a constant equals to 0. We're going to use this formula over here. We're also going to use this number 2, which says derivative of x dx equals to 1. Okay, so that means like derivative of x equals to 1. Next, we're going to have also this case where we have a constant multiplied by a function, or in our case, it's going to be x, and that's going to be equal to a constant, and we're going to take derivative of the function. And then I think this is pretty much what we're using today, or no, we're also going to have number 8, where we have derivative of u power n, which is n multiplied by u power n minus 1. So these are the formulas we're going to use in our problem today. So let's proceed. So remember, we are considering z as a constant, okay? First, we're going to calculate first derivative of x. And this is going to be, so I'm going to just say 4 multiplied by 3 multiplied by x, 3 minus 1. And this is the formula where you had derivative of u power n, and this was equal to n multiplied by u power n minus 1, okay? And then moving forward, we have 3x squared z. Remember, z is a constant, so I'm going to multiply 3 by z right away. And then we have x squared. I'm going to apply the same formula here. It's going to be 2 multiplied by x power 2 minus 1. Moving forward, we have 5xz squared. So 5 and z squared are constant, so I'm going to write them down together like this. And then now this formula over here is this derivative of cu. So I'm going to say derivative of cu, I guess, dx equals to, c comes in front, and then we have derivative of x dx, or I should say u, derivative of u dx. Okay, so if this is our case, our constant is 5 multiplied by z squared, and then we have derivative of x dx. We are left with derivative of x dx, and coming back here, derivative of x dx equals to 1. So now this is going to be multiplied by 1. And then moving forward, we have plus z plus 6z cubed. And remember, z is a constant, so we're going to treat this whole thing as a constant. And coming back here, derivative of a constant, c is the constant, dx equals to 0. So that means here we're going to have 0. And then 20 is a number, is a constant. Again, we're going to have plus 0. Now let's solve for this. We're going to have 12 x power 2 plus, this is going to be 6z x, okay, and then plus 5z squared. Wonderful. And now if you, well, this is z, it's confusing. You know, we always do z with the line because otherwise we can mistaken it for a 2. So I like putting the line there. So now if you look at the answers, you can find 12x squared plus 6zx plus 5z squared. And if you are tempted to choose C, I hope you think twice because we just did first derivative of f dx. We have to now take the second derivative. So the second derivative is going to be we're going to take the derivative of the first derivative. That makes sense. So now we're going to have 12x squared, which is going to be 12 multiplied by 2. We're applying this formula again, multiplied by x power 2 minus 1 plus, okay, and now 6 multiplied by z, it's a constant, and multiplied by x, this is the formula where we have a constant and the function, and the constant comes in front, and then we have derivative of that function, dx. And the function in this case, it's x. So, you know, dx, derivative of x, dx equals to 1. So here, we're going to come back and just say we have plus 6z, okay? And then this whole term is a constant, and derivative of a constant equals to 0, as we have here in equation number 1. So plus 0. And now if we solve for that, this is going to give us 24x plus 6z. And this now is the second derivative of f dx, 24x plus 6z. And the correct answer is B. A very short video for today. I hope you found it helpful. If you did, please subscribe and give it a like. Don't forget, to be able to pass the FE exam, you have to solve as many problems as you can put your hands on. So keep on working hard on solving the FE problems, and I will see you next week.